Turvalisäät on here.
In this example we have 3 firewalls and we use SRX 210 series, which are below. This firewall SRX 100 won't be used. Space propagates DHCP settings. Not forget to mention that in Juniper example this would be very tricky to do, but in our example this works out of the box, because the DHCP server resides in the same default routing instance as this interface. Then we have FE006 interface, which in our example is ISP1, FE007 interface, which in our example is ISP2. So FE007 interface, which in our example is ISP2. So I will show you how the dual WAN failover works. What are we going to do? We are going to ping our DNS server. Okay, so now we see that ping runs correctly, and now we will pull off the cable from the Juniper. The SRX box runs as the router. So basically you see here the blinking LED. This LED is the connected ISP1 interface. So now all the ICMP packets are running through this cable. If we pull the cable out, what will going to happen? The other ISP starts blinking. When we put the cable again, then theoretically the ISP failover should fail back to the primary ISP interface. What we see here? Yes, it does so. And what we see here, we have transmitted 84 packets and we have received 83 packets, so we lost only 1 packet, which is quite good for this kind of deployments. So now we're going to show how we access the firewall via the SSH management through both ISPs. So SSH, yes, and we have the access and the password ring. This also works for the Juniper example. Now we're going to try to access the second management interface from the second ISP. It also works. Perfect. Now we always have our management access. What we're going to do in case the default gateway is accessible. I mean, if the interface is online, then the virtual router will be online also, and it will forward the packets into nowhere. The gateway might become unresponsive and its interface might be online at the same time. Well, Juniper has an answer to this question. Juniper has the scripting capability. So if we take the real-time performance monitor probe while pinging some address or doing some other types of checks, and if we see that the address is unresponsive, then we can configure the event options to disable the ISP1 interface. So when the interface is administratively disabled, the corresponding routing instance is offline, and the traffic will egress the correct ISP2 interface. Gateway or the IP address we check becomes online again. Then we can enable interface, and in this case all traffic will egress ISP1. What we're going to use is the toggle interface slacks. Toggle interface slacks is the Juniper script file which can be used on the firewall. So this script toggles interface up or down based on passed arguments. In fact, it disables the interface in case the RPM probe is failure, and when the interface is disabled, then it commits configuration. But the RPM probes are continued, and in case the interface becomes online, I mean the provider interface becomes online, then the interface is enabled again and the configuration is committed. What we have here is the RPM probe. The probe type is ICMP ping, so what we do here is that we ping the ISP default gateway, and we do it from the source address of our loopback interface. And this is quite important, because if you don't define the source address, then most likely the LAN address will be used for that purpose. And in case the LAN address is offline, then no check is performed, and the interface is disabled. So this RPM probe periodically pings the default gateway. In case the result is successful, it sends a trap on the test completion, and it also gives this information to the firewall daemon, corresponding daemon. Here are test results for the RPM probe. As we can see, every 15 seconds the RPM probe is taken, and it calculates the round trip time. All our probes so far have been successful. This is the reason why the interface is online. So in these event options, the firewall checks for different events, and when it gets the event that the ping test completed, it's triggered, and it checks whether the interface is online, whether it is enabled. In our case, if it's enabled, then the script does nothing. In case the event gets a message that the ping probe has failed, then the script is triggered and it checks whether the interface state is disabled. In case the interface state is enabled, as we see for normal failover, we get the message that we cannot access our gateway, we cannot ping our default gateway. Then the script disables the interface FE006, which is the ISP1 interface, and it commits configuration. When the interface, when the RPM probe is successful again, then it enables the interface and again commits the configuration, thus making ISP1 virtual instance available. What we're going to do here is we're going to log into our ISP1 default gateway. As we've seen here, we have the firewall filter, which is currently inactive. So what it does, it blocks the ICMP packets from the source address 1111, which is the ISP1 interface. So let's activate this filter. Now, when we commit the configuration, then the SRX firewall won't be able to ping this interface directly, which it normally does, and it will disable the corresponding FE006 interface. Let's check. Communication is prohibited by filter, so let's check the interface status. Now the interface is enabled. Let's check the RPM probe results. Probe results. So here are our samples. As we see here, loss percentage is 100%. This information is forwarded to the corresponding daemon, and now any moment the FE006 interface should be disabled. Yes, now we see that it is disabled. Now what happens is that when we ping the same address, we can ping it again. Why it is so? Because the filter works only for the direct connection, and in fact we can ping it from the second routing instance. Now if we check the RPM probe, we see that the loss percentage slightly decreases, and if we see the history results, then we see that for 3 last RPM probes the request timed out, and for 2 last RPM probe they were quite successful. Now there are 3 probes, etc. Now the interface should be enabled any moment, but at the same time we can access the internet. Everything works fine for us. Usually the firewall disables the interface within 40 seconds. Well, it depends on the thresholds, but in my configuration it takes about 40 to 45 seconds to disable the interface, and it takes up to 2 minutes to enable the interface. So let's check whether it will get enabled. History results, 6 RPM probes. The configuration should be committed any moment. Okay, now I see that the device is quite unresponsive. It means that it commits the configuration. Now the interface is enabled again. That's how it's done. You can see the configuration templates, and you can also download the toggle interface Flex file in the Stallion's tips and tricks section on the web page.